All right, so I hope you printed your notes page because it really helps to have this diagram and it helps to be able to draw on here. So the largest empty circle problem is also sometimes referred to as the toxic waste dump problem. And basically what it's saying, what we learned on the previous lesson is that from any vertex, I can draw a circle because we know the distance between the vertex and A, D, and E here is the same. And drawing a circle proves it because I can get my compass here and I could draw a circle. And if I draw my circle, I end up with my circle going through all 3 points. See that? So I'm going to just highlight that circle, okay, just for reference. Okay, now let's take another circle. So from V2, I can draw a circle. Now I have to expand my compass. One of the easiest things to do is to twirl the paper rather than twirl the compass. That's what I do. Okay, so I can draw this circle here. Clearly you can see that it's a little bit bigger, and this circle goes through the nearest sites, A, E, and B. And then the last circle is through this one here, and I need to make this a tiny, tiny bit bigger. All right. Okay, so after drawing my circles, tracing them with the different lines, you can see that the red circle happens, visually you can see that it's got the biggest radius of them all. Okay, so we can solve the problem by drawing these circles, and this point V3 is the farthest away from any of these sites. Since this one has a smaller radius, this point here is not as far away from any of the 5 points as this one here. So let's do an example. Okay, so we've got this vertex. I'm going to call it V1, and I'm going to call this one V2. All right, so okay, that line isn't dark enough. Okay, let's zoom in. Okay, so from here to here, I can see that I go over 2, up 1, here over 2, up 1, here over 2, down 1. So you can see that my very teeny tiny radius that it's hard to draw a circle so small, but you get the point. So I'm calling this V1, right? So the distance from V1 to any of these points, let's just say C, is equal to x1 minus x2, y1 minus y2, right? So V is at coordinates, or V1 is at coordinates 0, 2, and C is the coordinates 2, 3, right? Over 2, up 3. So x1, 0, minus 2, and 2 minus 3. All right, so we end up with negative 2 squared plus negative 1 squared, which is 4 plus 1, so the square root of 5. All right, now let's figure out the distance from this one to the other one. So we know that if I drew a circle around this, I'm just going to draw a crude circle, but this circle should go through A, C, and D, just like we did over there on the previous example. And from this vertex, it went through A, B, and C. Well, visually, you can even see that the yellow circle is bigger. But let's use the distance formula to prove it. So I'm going to highlight just so we're clear. The distance from V1 to C is the blue circle, and we got square root of 5. So what about V2 to C? Okay, so V2 is at 1, 0, right? So the distance is going to be x1 minus x2, which is 2, plus y1 minus y2, which is 3. And we get negative 1 squared plus negative 3 squared. So we get 1 plus 9 square root of 10. And as I said before, you can visually see that the yellow circle has a larger radius. So find the empty circles for each of these, the largest empty circle. So the largest empty circle is this one right here. From the point, the largest empty circle is this value, and it's from vertex at 1, 0. Okay, I hope that makes sense. Watch this video again if you are a little confused.